Can you explain classification in ML?
Sure. Classification is the process of predicting discrete categories or class labels based on input data. It uses supervised learning algorithms that learn from labeled examples. Common algorithms include decision trees, logistic regression, and support vector machines, SVM. Example: a banking model classifying whether a loan applicant is high risk or low risk based on their credit score and income details.
What is regression in ML?
Regression predicts continuous numeric values rather than discrete categories. It estimates the relationship between dependent and independent variables. Popular algorithms include linear regression, ridge regression, and polynomial regression. Example: predicting the future sales revenue of a product based on advertising spend, price, and seasonal trends.
What is clustering?
Clustering is an unsupervised learning technique that groups similar data points together based on their features. It helps discover patterns and natural structures in unlabeled data. Common algorithms include k-means, hierarchical clustering, and DBSCAN. Example: a telecom company using clustering to segment customers into groups like heavy users, moderate users, and light users based on their call and data usage.
What is dimensionality reduction?
Dimensionality reduction simplifies data by reducing the number of input features while retaining essential information. It removes redundant and noisy features, improving computational efficiency and visualization. Common techniques include principal component analysis, PCA, and TSNE. Example: reducing thousands of gene expression features in bioinformatics data into a few key variables for easier analysis of disease patterns.
What is semi-supervised learning?
Semi-supervised learning combines a small amount of labeled data with a large amount of unlabeled data to improve model performance. It is useful when labeling all data is costly or time-consuming. This method bridges supervised and unsupervised learning. Example: training a medical image classifier using 1,000 labeled MRI scans and 10,000 unlabeled ones to detect brain tumors.
What is self-supervised learning?
Self-supervised learning is an approach where models generate their own supervision signals from unlabeled data. They learn by predicting parts of input data from other parts. This method is widely used in natural language processing and computer vision. Example: a language model like GPT learning to predict the next word in a sentence using millions of unlabeled text documents.
What is online learning in ML?
Online learning is a technique where models are updated continuously as new data arrives, rather than retraining from scratch. It's ideal for streaming or real-time applications that require constant adaptation. Example: a real-time fraud detection system that updates its model instantly when new transaction data is received.
What is batch learning?
Batch learning trains the model on the entire dataset at once and doesn't update until retraining occurs with new data. It is suitable for static data environments. Example: a movie recommendation system retrained monthly using all user ratings and reviews collected during that period.
What is transfer learning?
Transfer learning reuses a pre-trained model on a new but related task to save training time and resources. It's especially useful when the new dataset is small. Example: using a pre-trained image recognition model like ResNet, trained on ImageNet, to detect defects in manufacturing product images.
What is active learning?
Active learning allows the model to interactively query for labels on the most informative or uncertain samples. It reduces the effort and cost of labeling large datasets. Example: in medical imaging, the model flags ambiguous X-rays for expert labeling, improving accuracy while minimizing manual labeling work.
Well, I'm happy to say you are selected. Congratulations.
Thank you, sir. Thanks to ZoomInData for their real-time projects, mentorship, and constant support. From confusion to confidence, that's my ZoomInData story.